AI agents that matter. So Princeton just dropped this paper July 2nd, I think, and I was reading it, and I wanted to dive right into some questions about the paper, but then I realized we are existing in like a multi-definition world of AI agents right now because it's gotten so popular. So there's the kind of original textbook definition, or even pre-Gen AI, right? Which is this computer system interacting with some environment and taking that in and making an action, right? Which is like broadly applicable and often how the academics are referencing it. It's sort of how it's being referenced in papers because they're academics. However, you have like Microsoft over here that's thinking about this as like sort of Gen AI specific environmental sensor driving an LLM driven response, right? And so like these are fundamentally like roughly the same things, but like we are hearing about the Microsoft version of AI agents all the time and then reading about the advancements from a textbook. So like AI agents, like help me out here, like before we're talking about what matters, like what is the definition that people are operating off of?
Yeah, I think a simple way to understand it is you think of LLMs, you think of ChatGPT is kind of the first thing that comes to mind. You go to ChatGPT, you give it a prompt, it gives you a response. ChatGPT in that environment is a good example of an LLM that's operating without any precise set of instructions. It does have access to an environment, and you can say that the environment in that case is your prompt box on a UI. And in some cases, you can ask ChatGPT to make a web search. And in that web search, it's like a tool. So you have access to a search engine. You can go look up some websites, some content from a specific website, and then bring some results back. So if you put all of that together, right, and if you, let's say, give it a command, and that command now, when we talk about LLMs, there are two types of prompts. There's the system prompt, which is the personality that you can imbibe to an LLM. It's like an instruction that operates in the background. You set it once, and ideally, you won't keep changing it often. And then you have a bunch of user prompts, followed by assistant prompts or agent responses to your user prompts, right? So in the simplest way, if you think of agents, they're like a specific instance, a configuration of all of these parameters designed to achieve a specific goal. Now you would define that goal in terms of your system prompt and some extent of your user prompt. You would put it in an environment, which would be an application. It could be an API. It could be literally anywhere you want an LLM to do meaningful work. You would give it access to some tools. That tools could be a database, like, hey, I want you to take some input and store some value to a database. It could be web search. It could be literally anything that uses simple English, that has a schema, and that you could predictably define beforehand programmatically. And when you put all of those together, what you have is an agent.
And so I think for the last year, there's been a lot of excitement about the ability for an agent to plan and then execute. And we see as it gets further and further down the chain that the likelihood of you achieving your results is going to go down, right? Which isn't too different from giving like a toddler a set of instructions, right? So what we're trying to do with this paper, it feels like, and agents that matter is like provide a clearer benchmark so we can understand like how much progress it's actually being made. And there's a open question on, is accuracy the only thing that matters? Is accuracy and costs at the optimization point, which the paper talks about? What's really important here, because we're trying to achieve a task at a cost. So what's your perspective after reading the paper?
I think there's two very important points that you bring up here. I'd like to talk about them separately. One is accuracy, which is super important. As you would understand, accuracy is basically a prediction of the measure of a difference between what was expected and what the model produced. And there's all kinds of metrics and KPIs you could use to measure accuracy. There are a lot of benchmarks these days. The SWE bench, for example, is one of those. There's many others that are meant to like evaluate how good an LLM is at solving specific tasks. Like in that case, it was GitHub, just solving GitHub issues, creating diffs. In many others, it's producing meaningful outputs that you could, otherwise give to a human. But in these cases, one interesting thing that happens is when you talk about data sets in machine learning, you have typically the training set and the test set. Those are universally understood. But you also have, in some cases, the holdout set. And the holdout set, think of the holdout set as an extension of your test set. And you would, typically you would take a big data set. Maybe you take like 95% of it and assign it to your training set. Sometimes it's 95, sometimes it's 80. And then 20% of it to your test set. And what that means is all of your training set data, it's going to be presented to the model that, hey, this is an example that you're learning from. And think of it as instructions that you would give to your toddler. And then you would run the process of training, which in many cases is converging using gradient descent, the process of deep learning. We've talked about that. And then your test set is meant for validating the model's performance. So you've kept aside a portion of the data set. It's homogeneous, so it's very similar to what the model has already seen, but it's net new examples. And your assumption is if the model has trained well to that data, it will be able to see these net new examples and predict the expected label. It's very straightforward if you think of it that way. But then the reason you also have a very small holdout set is that in all of this, because you have all this data going through it, there are some chances where the model can overfit the data. And what overfitting means is you have a model that's designed to, let's say, solve coding exercises, but somehow the examples you've given the model are all of a certain type. And it's not always easy to detect that, that, hey, I'm always trying to, let's say, execute a specific algorithm. Somehow all of my examples are landing to that basic algorithm that's reflected in all of my examples. And then the problem that creates is the moment the model sees an example that requires it to apply a different algorithm, it's not going to be as good. It's going to have relics, if you will, of this old method that it has learned that it tries to apply in that situation, and it comes up with the wrong answer. So with a small holdout set, and when you're having these data sets and benchmarks public, the challenge with that is your latest state-of-the-art models are trained on terabytes of data. They've indexed literally big chunks of the World Wide Web, right? So you want to keep some of these holdout sets as private. And when I say private, I mean secret. And the reason for that is you want to make sure that the model has never seen those examples, right? Because if your data is public, then most likely everything in your training and test data set is also public, right? But having that holdout set private is immensely valuable because that is what you would define as, the main factor of evaluating a model's performance. Yeah. And then what the paper talks about is that many of these benchmarks and data sets out there, they don't have holdout sets, and the creators don't have any intent of creating a holdout set. And that is alarming in some way because when someone talks about, hey, I achieved a 51% score on this data set, right?
It's like they already saw the answers.
Yeah. You have no idea if it's overfit or if it's really being able to, perform that well on that data set.
And so, I think the paper is highly skeptical of sort of like the existing landscape of benchmarks, which makes sense if you think about where we're at in the landscape, right? Like relatively new technology, an attempt to measure some level of accuracy. There's not a ton of incentive to develop an incredibly objective benchmark out the gate. Like as folks are figuring things out, it's rather better to just get something out and start having a conversation about it. And we can now take a step back and say, okay, like how should we be objectively measuring things? So I think this will kind of work out in the long run. I think the challenge is figuring out now, like, how can we create a standard and what should that standard be? Because it feels like incredible progress is being made, but how quickly, right? Like at what order of magnitude? We have a pretty good sense from a transformer perspective, the order of magnitude growth every year being like really like almost like 10x from a performance basis. But from an agent, it's much more complex what we're doing. And I don't know if you have an opinion on how we should even be thinking about measuring this.
Yeah, I think the paper does a good job of proposing, what a benchmark should have. Like, for example, the holdout set. Yeah. For example, making sure that the test set is not something the model has seen, reducing the chances of overfitting on all that data. But while we're thinking about all of these numbers and all of these metrics, one interesting example comes to mind. You mentioned about the path to the future, right? A lot of people think that we're at the crossroads where we're approaching AGI, artificial general intelligence, if you will, and some people have questions about, is LLM the architecture that will lead us? Is transformers the architecture that's going to lead us there? Are LLMs capable enough to do AGI kind of things? So it probably helps to define what AGI is, and what our thoughts are on that. So AGI, artificial general intelligence, it has been expressed. It's not a new term. It has been imagined, expressed, demonstrated in movies, even in multiple forms. People have their own ideas about it. But in today's world, in the context of LLMs, an LLM by itself, if you give it a net new skill that it has to learn, right? You compare that to a toddler. Give it a puzzle, give a toddler a puzzle and ask them to figure out how to join them. As they spend time on it, they will learn to do it. And LLM, in comparison, you would have to go through a process of maybe fine-tuning one LLM that does something relevant in that space to be able to give it that skill and to be able to achieve, the goal of fine-tuning. And we've seen that these agentic AIs, LLM-based AIs, they're great at solving those tasks when they're fine-tuned, right? That is what we were talking about earlier with people like exceeding scores of benchmarks, setting new standards. We are now the state of the art. We can do 50% of that index and yada yada and so on. But that's all a result of fine-tuning. And we were talking about overfitting earlier, where that's relevant. The difference with AGI is very much like will be very much like the 5-year-old, where you give it a new problem and it acquires the skill to solve that problem. Yeah. And if you talk about, with that definition, if you talk about LLMs, we're far away from that. There was this interesting conversation on the Dwarf Case podcast with Francois Chollet, where he talked about the ARC AGI index and the ARC AGI dataset, and how they've been careful in designing these challenges that are very easy for 5-year-olds to solve, but then LLMs struggle on that. So yes, there are many examples of misleading performance, misleading notices, and then data sets that aren't being designed as well. But I think as the space is evolving and as papers like AI Agents That Matter are coming out, we'll be able to make more definitive progress towards better indexes, better policies of indexing data by LLMs, and better metrics for evaluating LLMs.
Yeah. So your perspective is transformers, not the path to AGI, probably the most revolutionary technology of our lifetime.
Yes.
And so even if it's not the path to AGI, it's okay.
Yes.
It's okay. We've
totally.
invented basically a new computer at this point, like a probabilistic computer. And so it's interesting, almost the obsession with AGI versus saying like, wow, like we've unlocked so many new use cases. The enterprise is about to just completely change. Like the way that we think about the cost structure of a business is going to be like a relic of the past. And be quite excited about that, as opposed to being let down that AGI might not get here in the next few years here. I mean,
absolutely. And I think that's a fantastic point you bring up about cost, right?
Yeah.
I said I'd talk about cost.
I knew I'd get you.
Yeah.
Here we go.
Yeah. And cost is super interesting. So when we if you look up GPT-4 or open up that OpenAI pricing page, you'd see it's a few fraction of cents to get on a per token basis, right? And the price keeps going down. But if you look at what the paper says and what they tested, right, with these agentic frameworks, and when I talk about agentic frameworks, what I'm referring to is multiple agents coordinating and working together. So here's an interesting statistic. I read at one place that ChatGPT is only 65% accurate at generating code. And when I say ChatGPT, I simply mean GPT-4o from a programmatic API standpoint, right? The thing is, when you put multiple agents together and have them solve a specific task, and maybe that's related to code generation, right? Transforming a requirement into code, you would have that 0.65 multiplier on that task, right? So you would do 0.65 into 0.65, which is a much smaller number.
Yeah.
And then as you add agents to that chain, you are progressively reducing the probability of getting a high quality output if you are simply putting them serially and not having the correct metrics and the correct guidelines in place to monitor the code quality. And that reflects in the paper's observations. So what they mentioned was they had to do several runs, chains of runs, sometimes tens or multiple double-digit runs of single prompts to get to a meaningful answer. So at that point, are the LLMs really solving the problem, or is it just monkeys throwing stones at a wall and hoping something will stick, right? So that it brings up that kind of question. But that's not to undervalue the performance of LLMs and the fact that they are ultimately able to solve, which is phenomenal, right? But at what cost, right? So they realize that solving a task on an average costs about $4 for an LLM, and that is actually alarming. So if my agentic workflow task costs me $4, and that's like not even highly complex, right? So as I grow that problem in terms of complexity, in terms of scale to much bigger, solutions, it quickly becomes unsustainable. So that I believe is a very important contribution and discovery that this paper has made. Yeah. And it is something for us to be aware of, and I'm pretty sure the cost will go down. But in terms of designing architectures and designing frameworks that work around these limitations, it's super important to take them into account and address them rather than just relying on probabilistic outcomes and then running things multiple times. It's very hard to build deterministic systems around those limitations.
Yeah. I think the average technology investor is probably right to not worry about cost on a 10-year time horizon fund, certainly, right? Like we've seen Moore's Law take over time and time again, and I don't know why it wouldn't here, but if it's not something to ignore if you're trying to implement agentic workflows as an enterprise today and being thoughtful about it. I think that insofar as it's cheaper than the alternative, it's great and it makes sense, and you should operate now. I think the concerning part from an enterprise perspective is much more the 0.65 times 0.65 times 0.65, because even as you ramp up towards 0.9, you start multiplying that 1 or 2 or 3 or 4 workflows in a row, like your outcome isn't very helpful. And so like, how do you think about solving for that and taking advantage of the power of these LLMs while understanding these chain of events might not lead to the reliable outcome, at least in some of these initial test runs?
Yeah, I think one thing that everyone knows LLMs are great at generating text. Yeah. And when that text becomes code, that's when the 0.65 factor comes in, because it's not just about writing code, it's also about making sure it compiles, making sure it follows stylistic guidelines, making sure it honors API schemas. So as you can see, there are these bunch of external entities and factors that come in that the code must live up to, right? Just to be right, as opposed to simple English text that anyone can understand. Yeah. And so there are creative ways to make that more deterministic, to make that more predictable, that we as a company, Blitzy, have been experimenting with and have found success with. One of those is if you rely on pre-written code. If you think of code as a repository, as a library of functions that exist, and then you spend the LLM's time and energy in orchestrating those functions, that pre-written code that's already been tested, so the externalities are accounted for, then you reduce the complexity of the problem, because you're no longer thinking about, hey, is the API schema correct? Is my LLM's knowledge up to date? And is that aligned with that version of the schema? Has this bit of code been tested in isolation and as well as all together? You reduce the testing problem from the isolation standpoint to a combined entity standpoint, which is simpler because now you have all of these models together. You know what the code is supposed to be doing in aggregate, and you know that in isolation it just works. So by reducing the complexity, by reducing the externalities that are involved to make something work, you're making it an orders of magnitude simpler problem and increasing that 0.65 number to a much higher, a more predictable number, as well as not having as many multipliers in the middle.
Yeah, so you really remove the chain multiplier, so we're not multiplying by point whatever it is 8 orders down the line, but make every individual action independent in nature and really only reliant on the things that it touches within the code base. We're drastically reducing our errors. We've seen, it's so interesting, like we've seen kind of like off the shelf LLMs be pretty solid at like things like unit testing and code review and really struggle at the front end of the process, meaning like the initial creation of what is supposed to be a product. And so marry these two worlds up together in some reinforcing pattern, like we're in a pretty good spot as a company, as a society. It's quite interesting. So I want to circle back to AI agents that matter, the paper, the takeaways here. Like if you had sort of someone didn't want to read the paper, they want to nerd out, the big takeaway from AI agents that matter, the paper that just dropped July 2nd, what is it?
Well, I would say the top takeaways from that paper are, hey, there are a lot of benchmarks and sets out there. There are a lot of great innovations happening in LLMs, but not every benchmark is accurate.
Yeah.
And this is a case where the judges and the rules of the game are not watertight, if you will. So
it's a huge problem if you're a capital allocator, right?
Exactly.
It's a big problem if you're a capital allocator.
Yeah.
Whoa, wow.
Yeah. If the game is flawed, can you blame the players?
Yeah.
So it's that kind of a situation. So don't believe all these exaggerated numbers out there unless you validate that the data set really checks the right boxes, has done their homework in terms of defining secret holdout sets, in terms of making it difficult for anyone to game the system and to overfit or to anticipate the kind of challenges that they would see on that data set. Because fine-tuning is easy. There are many great services out there like AnyScale where you can go ahead, bring some small sample of data, fine-tune any of the great open source models like Llama 3 or whatnot, and then have these models specialize on specific tasks. So the soul of the paper is that it doesn't make sense just to gloat on numbers, but what we need is a framework that is reliable, dependable, and that you can believe when you see high numbers quoted about. And then the paper also talks about why agentic workflows do have a high cost today. And it does talk about the cost going down and then ways to reduce that. But the key really is there are a lot of agents out there. Not every data set and every agent trained on that data set matters. So pick your choice of tool, agent, framework, data set carefully.
This is hard though, because like if you're an enterprise and you're thinking about working with a company, right? Like I want to just be able to look at SWE benchmark and figure out which one got the highest percentage point. And like, the person buying or making this purchase decision is not a AI expert, right? Like, so what's the simpler answer for them, right? Like I'm a CFO and we're going to make a bunch of AI investments and we want to do something that's going to help on the programming side, right? Like we spend a lot of money on engineers, right? Like, and I thought it was going to be easy because we had this thing. Like, what are the 2 or 3 things that CFO should be actually asking about to evaluate this? What are going to be significant budget decisions?
That's a great question. I think the most important question for that CFO to ask is, fine, I get it. There's some data set out there. They have some benchmark. There are some models that are performing really well on that benchmark. But I need to know that for the data that I have, can I use it with this LLM-based process? Is it meaningful? Is it valuable? Do I have enough data to use there? And then how does that model perform on my data set? So if I were that CFO and I were being pitched based on these numbers, I would have them test against a small subset of anonymized data that I would have set up and judge based on that, in terms of maybe a qualitative outcome if you don't have the time to create metrics out of that. And how well is that model performing relative to the other options out there? Because if you the models that we are seeing today, like Claude 3.5 Sonnet, is currently at this time of recording this one of the best models out there. And it's if you compare that with the previous version of Claude, it's clear that the models will continue to get better.
Yeah.
And the cost of fine-tuning models will also go down as the cost of inference is going down as well, right? So for that CFO, the call that they need to take is, do I need to pick up this model that someone has trained on some data that can do something and maybe works in some of the cases? Or do I have the resources, the time, and the talent to invest in to maybe fine-tune my own model internally and see how that does, right? And that's a meaningful shot to take. But they don't have to do all that internally if they don't have the talent, because a lot of this is, these senior leaders realizing that, hey, AI is a thing and we've been hearing about it, but I just haven't had the time to allocate resources to it. We do have an AI strategy maybe, but we don't really have a roadmap. So I think it's also a great opportunity to collaborate with the startups out there that are addressing this very specific problem. And it's quite a win-win there, because you have as an enterprise, you have the data, and the startup can help you quickly get running with that data, while you build maybe your internal team that can spearhead the direction for the company overall.
Yeah. The war on AI talent is outrageous. The challenge is there's this massive rebrand from a bunch of engineers that are trying to masquerade as sort of like what they're calling themselves, like AI engineers. Like no one called themselves an AI engineer a few years ago. But I think what we've seen is like that if you really are quote unquote like an AI engineer, you have total optionality, and you've probably already made your money, right? Like you've already made your money in life, and they're choosing where they work very specifically, and they're not choosing to work at a large legacy enterprise. And I think because we get this question all the time from older HPS execs that are reach out to, because they're like, oh, Sid went to NVIDIA, he knows a thing or two about this, right? And the question is like always the same. Oh, like how do we get like guys like you to come work at places like this? And it's like, well, the tough thing is you're not going to be able to, right? Like there's not a dollar amount that's going to incentivize these people to show up, right? And so it's like the better question is like, how do we get really good at partnering with people that are really good at this, right? Like how do we gain a deep level of understanding what they can do, sharing what our jobs to be done are, and collaborating? I think like that's the really smart executive. That's the question that we see them asking, and it's quite interesting.
Yeah, and you bring up a very important point about AI engineers. Like, I don't believe the AI engineer exists.
Yeah,
I think there are
some data scientists and some full stack.
Exactly. Yeah, it's creative branding and it works. And I totally respect
product marketing
that.
From the engineer's perspective.
Yeah. I respect that being the same thing. But what does exist are really good engineers who know how to use the tools well. 99% of the cool things that you can do with AI in the market today, you can do if you're a great engineer. You don't need to reinvent the next version of GPT. What you need to do is be able to use the API, build applications that scale, address the challenges and limitations, know what they are in the first place, right? And then address them in solutions. And this is what great engineers have been doing with technology for years. And the ones that are really good at that are able to command a premium in the market, because they know that, which is great. But for these executives, hiring them is not going to be easy, because they don't want to work for you if you don't have an AI strategy. Everyone has an AI strategy on paper, but if you really have an AI strategy, it will show in your company's bottom line. It will show in the products and the things that your company is doing. So again, like I said earlier, the fastest way to do that is to work with maybe a startup that does that for you, sets that up as you build that internally, and create promise for the AI talent out there that you are serious about this, and they're not going to come and work on some boring projects, but it's the next best thing for them.
Yeah. Some would say the fastest way is to just work with Blitzy, but
Exactly.
Yeah. Kickstart, instead of there's more to a strategy than PowerPoint slides. There's code, right? Like there's building, and we see like the other piece of, I would say, you should probably create some small AI product within your company, so that the AI engineers, the engineers that are coming on board to work on your AI work stream, like aren't starting from a blank slate in a multi-billion-dollar enterprise, right? Like that's a hard spot to be in, and to we've heard these directives from public board members, I always say, where their directive is to AIify the company, right? Like, what is that? If you're an engineer and you're getting hired in and your directive is to AIify, you're like, okay, what, right? Like, that's a really hard spot to be in. And so, like, you can come in, have an initial application within your existing workflows that automates something that has an AI workflow. Like, all of a sudden now you have an existing work stream where you're like, hey, you're going to come work on this project, and then some engineers from this project are going to go work on the next one, as that's on our roadmap next quarter. It's a much more comfortable place to land from a talent perspective. So
if you think of the engineer's mindset, right, they're thinking about, what do I get to build out of this opportunity? And
it's their time, man. It's
very precious, right? And it's like, how does that go on my resume? How does that look at it? Not everyone is motivated the same way, but that definitely is an important consideration. How does this look on my profile in the next 5 years, right? And they're coming in and you're saying, you want to AIify the company, and maybe you have some budget allocated, but you're not telling the engineers what you want them to do. And they're not going to be good at telling you what you should do, right?
Because if they're great engineers, they're probably not, because they've spent years and years mastering the craft. Right.
Exactly. And then if you're not sure about what your strategy is, and you send them in a few directions, and then you reject those just when it starts making progress, which is what happens, right? You happen to reprioritize because you don't know what your focus is. They're going to be really frustrated because I set out building this, like I got emotionally attached to it. I invested my time, my hours into it, and now it's scrapped. So you don't want to be in that position, which is why you spend the time to figure out what the strategy is, what's most important to you, what creates the most impact on your top line or bottom line from a KPI standpoint. You set some projects in motion and you show your commitment to that. I think back to something like CUDA from NVIDIA days, right? CUDA was something that started way back in 2006, mid 2000s, and then Jensen was so focused on that. I believe it was like an intern project at one point that matured into a real product, and everyone thought that it was not very smart to continue building it, but Jensen just did it. He just saw the future. He believed in it. He continued to hire for it. He continued to allocate budget to it and to grow that line. And then look at what CUDA is today. Some people consider CUDA to be NVIDIA's moat. So that's like a hallmark, a highlight of commitment to the company. And the reason it survived was A, because he stood behind it, and B, he invested in it. He made it a product. He forced the company to adopt the UDA, or the Unified Drive Architecture, which simplified CUDA's adoption eventually. So if you want engineers that are world-class, that make your company grow in the direction that you want to, you better be ready to make the commitment and to put your money where your mouth is.
I think that's right, and I think demonstrating that commitment is a challenge for a lot of these enterprises, and getting started yesterday is probably the right decision to do so. I just got to interview a candidate who's frustrated because they've launched 3 different cloud environments and a hybrid environment as a part of their AI strategy, which is there is no strategy. It's just like he's like, well, we're gonna launch Azure, we're gonna launch GCP, we're gonna launch AWS, we're gonna and so he's like, now I'm managing 4 cloud environments, and not because it was a deliberate strategy and we were using them for different purposes. He just like every quarter we just did a different one, right? It's like and he's like I am capable certainly to do this. Are we gonna just like use something I've never heard of next quarter? And it's just like it's quite frustrating for him. And so I think the clear opinion up front, the openness to innovate, clear opinion up front on what you want to do is is such a value add. So any other, what paper should we talk about next week?
Yeah, I think there's a bunch of papers about RAG that I've been exploring. And I have a post in the pipeline about why LLMs are bad out of the box at coding. So stay tuned for that.